Hi, I'm George Woodbury from College of the Sequoias, and in this video, the third of 4 videos related to partial fraction decomposition, we're going to learn how to handle the case where one of the factors, or more, are quadratic. So here, our denominator is x plus 3, which is linear, and we're going to start the same way that we did in the previous videos by putting a over x plus 3. But when you've got one that's quadratic, x squared minus 5, we need to use a different type of expression in the numerator for that factor. And that's going to be a linear factor of bx plus c. So if we had 2 quadratics, we would have ax plus b and cx plus d in the numerator. Anyway, then we can go at this in pretty much the same way that we did before. Let me get rid of that, because we're going to need the real estate. And if we multiply through by our common denominator, which is x plus 3 times x squared minus 5, the left side becomes just the numerator, 8x squared plus 4x minus 32. The right side, the x plus 3's divide out, leaving a times x squared minus 5. For the second one, the x squared minus 5's divide out, and we're left with bx plus c times x plus 3. So the x squared minus 5 is a little bit of a problem because we don't know what value of x to use to make that term disappear to be 0. So really, the only thing we can do at the beginning is start with -3, because that'll make this term equal to 0, which makes all of this equal to 0, and maybe we have something that we can solve for a at least. And then we can use a system of equations to try to get b and c. And I'm actually going to show you a couple of ways to do this one particular problem. Let's start with x equals -3. We've got 8 times -3 squared plus 4 times -3 minus 32. Just put in -3 for every x. That's equal to a times -3 squared minus 5 plus -3b plus c times -3 plus 3. That whole term is 0. So a lot of arithmetic to do here. On the left-hand side, that's really 8 times 9, or 72, minus 12, minus 32, that is 28. Use your calculator to verify that. On the right-hand side, we've got a times 9 minus 5, or 4. That gives us a equals 7. Just divide both sides by 4. So we've got the first fraction taken care of. Now we've got to come up with values for b and c. So we're going to get a system of 2 equations and 2 unknowns by substituting in convenient values for x. Well, actually, that's not really true. We can do this a little more efficiently if we use x equals 0. Because if you look at bx plus c, if we put in 0 for x, that's going to, b times 0 is 0, that's going to leave just c, and then we'll have something that we can work with as well. So let's try that. X equals 0. 8 times 0 squared plus 4 times 0, that's a whole bunch of 0 there, minus 32. So the left side is going to be -32, equals, our new value of a is 7, times 0 squared minus 5, plus b times 0 plus c times 0 plus 3. All right, let's simplify. Like I said, that's -32. On the right-hand side, 0 squared is 0, minus 5 is -5, times 7, that first term is -35. b times 0 is 0, That leaves c times 3. Add 35 to both sides, we get 3 equals 3c, c equals 1. So now we have part 1, second part of our solution. Now we just need to figure out what b is. This is where we're just going to have to pick a number that we feel like working with, and we might as well use 1. Small, easy to do arithmetic with. So round 3, we're going to use x equals 1. And again, I'm going to replace a by 7, and I'm going to replace c by 1. 8 times 1 squared plus 4 times 1 minus 32 equals 7 times 1 squared minus 5 plus b times 1 plus c, which is now also 1, times 1 plus 3. The left side, that turns into 8 plus 4 minus 32. That's negative 20. On the right side, 1 squared is 1. 1 minus 5 is negative 4. So 7 times negative 4. The first term is negative 28. Plus b plus 1 times 4. I'm going to move over the 28 by adding it to both sides. And I'm going to distribute the 4 to what was left. 4b plus 4. Distributing that 4 in. Subtract the 4. 4 equals 4b. b equals 1. So we've found all 3 constants in the numerator. We're going to replace a with 7. B and C will both be replaced with by 1. 7 over x plus 3 plus 1x plus 1 over x squared minus 5. And of course, the 1x, we can just write that as x. So there's the partial fraction decomposition for this rational expression, 8x squared plus 4x minus 32 over x plus 3 times x squared minus 5 is equal to that partial fraction decomposition. Now I mentioned there's a second way that we could have done this using a system of equations. And let me show you how that goes. You may prefer it to this first method. Myself, I like the first method a little better, but everybody's a little different. So let's take a look at another way we could do this. What we can do, and I've just picked up the equation after we cleared the denominators. We can simplify or expand and simplify the right-hand side. So 8x squared plus 4x minus 32 equals, distribute the ax squared minus 5a plus FOIL style multiplication on the right hand for the product. Bx times x is bx squared. Bx times 3 is plus 3bx. C times x, that's plus cx. And finally, c times 3, that's 3c, c times 3. Let's group terms on the right-hand side by their degree. So ax squared and bx squared, I can write that together as a plus b times x squared. Then I can take the terms of degree 1. I've got this 3bx and a cx, so plus 3b plus c times x. And finally, I can pull the remaining 2 terms, which are constants, plus negative 5a plus 3c. And that's still equal to 8x squared plus 4x minus 32. What I'm looking for are values of a, b, and c such that a plus b equals the coefficient of the squared term, 8. And 3b plus c equals the coefficient of the linear term, 4. And the constant, negative 5a plus 3c, is equal to negative 32. So I've got a system of 3 equations, 3 linear equations, and 3 unknowns. We know how to solve that. Let's see, what would be a good idea here? We could use, let's use substitution. So I know that A is the same as 8 minus B. So I can substitute 8 minus B here for A. That's going to be negative 5 times 8 minus B plus 3C equals negative 32, or negative 40 plus 5B plus 3C equals negative 32, or moving the 40 to the other side, getting it into that general form, 5B plus 3C equals 8. So I do have 2 equations that just have B and C in them. And I can come up with the solutions for B and C, and then I can back substitute to figure out what A is. Let's give this a try. By the way, remember our values for A, B, and C we found to be 7, 1, and 1. Next step, let's rewrite the 2 equations we're going to work with. 3b plus c equals 4. 5b plus 3c equals 8. This time I'm going to use elimination, and I'm going to eliminate the variable c. I can do that by multiplying the top equation by negative 3 on both sides. So that will give me a negative 3c to cancel or eliminate the positive 3c in the other equation. Distribute through the negative 3, negative 9b minus 3c equals negative 12. Copy over the other one, 5b plus 3c equals 8. Negative 4b equals negative 4. b equals 1. Come back to one of these 2 equations. I'm going to use the top one. 3b, so that's 3 times 1, plus c equals 4. Subtract 3 from both sides, c equals 1. And finally, I can come back to where I made the substitution. A equals 8 minus b. A equals 8 minus 1, or 7. So I get the same 3 coefficients, and that may seem like that may have gone a little quicker than the other one. So you've got to try to decide which one works better for you. Both approaches will work every time. You just want to try to find the one that's more in your wheelhouse. All right, that's it for that one. We'll do one more partial fraction decomposition in the next video.